the math section of the SAT. This is from a bundle that I saw on College Board. I'll leave the link below. I won't cover specific topics, I'll just cover the math section as a whole. So, question 1. A group of students voted on 5 after-school activities. The bar graph shows the number of students who voted for each of the 5 activities. How many students chose activity 3? So, here are the answer choices. And you can see on the x-axis, the bottom part of the graph is called the x-axis, or the horizontal part of the graph is called the x-axis. The y-axis, which is the vertical part, gives you the number of students. So here we see activity 1, 2, 3. We're focused on activity 3, so let's pay attention to that one. You can see that each line here goes in intervals of 5. So you can either count each one of them, or you can see all the way where activity 3 reaches, and you can see it's between 35 and 40, and it looks closer to 40, so we can guess that it's 39 or 38. Then we just double check with the possible answer options, and we see 25. That's not anywhere we got here. We see 39, 48 is way too far, and 50 is way too far. So the only one remaining with our estimates is B, 39. What percentage of 300 is 75? Here, I like to use this method called the is of method. So it looks a little something like this. Is of. So what this is showing is that look at this sentence, and you'll know which one goes in the numerator and which one is the denominator. So it says, what percentage of 300 is 75? Is 75 of 300? So you can see that of is 300 is 75. Now what do we do with this? We set this equal to a fraction of a percentage. And we know that a percentage is, to represent a whole, that would be 100%. So you would just need out of 100, right? And you're trying to figure this part out. You don't know what 75 is percentage-wise to 300. So what you would do here is you could do what I know as the butterfly method. You would multiply these two numbers together. And then you will solve for x. So 300 times x gets you 300x. And you set that equal to 100 times 75. Now, when you're multiplying anything by a multiple of 10, you know you could just add the zeros next to that number. So for example, we have 75. 100 has 2 zeros next to it, so we just put 2 zeros, and there you go. Now here we just solve for x. In order to do this, this right here is a one-step equation, because you need to do one thing in order to solve for x. So here we would divide by 300. Divide by 300. The reason for that is because you're multiplying 300 and x, so you have to do the opposite operation in order to get rid of the number next to x. So we're dividing by 300, and since we're doing it on this side, we have to do the same thing to this side. This helps balance out the equation and keep it equal. So now we have x, 300 cancels out 300. Now what is 7,500 divided by 300. Here we can see that there's zeros at the end of both numbers, 2 zeros to be exact. So you can honestly ignore them. So they kind of cancel each other out. Now you're left with 75 divided by 13. And that should get you 25. So now we know what x is in this equation. So 2500. This is the equivalent of 25%. So here's your answer. Question 3. What is a solution to the given equation? Here, we have to know the order of operations because you have to do two things in order to solve for x. So, we know P, E, M, D, A, S, PEMDAS. P stands for parentheses. E stands for exponent, which would be the two on the top right. M is multiplication. D is division. A is addition, and S is subtraction. So basically, this tells you what order, when you are doing an equation, this tells you what order to go through. However, when you are solving for an x like this, you work backwards. So here we have an exponent, and we also have a division. So let's work our way backwards. Do we have subtraction? No. Do we have addition? No. Do we have division? Yes, we do. So what we would do here is we would do the opposite of the division. So since we are dividing by 25, we would multiply by 25. So 25 times. The 25s cancel each other out, and you're left with x squared. 25 times 36, that should get you 900. Now, what do we do here? The last thing, we can keep on working backwards, looking at our list. So, multiplication is x. There's none. Is there an exponent? Yes, there is. So, when you do an exponent, you want to take the square root. And I'm pretty sure you could use a calculator with this. It's been a while since I took the SAT. But I'm pretty sure they allow us to have calculators. So if you pull out the calculator and you take the square root of both sides, you get that x is equal to 30. Alright, question 4. This is a word problem that you're trying to turn into an equation. Now, the important thing to look at here is keywords. So, more than, times, and equal to. So, let's start off with the easy part. Equal to 83. So, we know that a whole equation is going to be equal to 83. Right? And that's it. Equal to 83 doesn't give you any other information regarding 83. So if you're having trouble with this, you can also use the process of elimination. These three answer choices have 83 next to an equal sign. However, B does not, so we can count that one off. So now let's look at the rest of the information. 3 more than 8 times the number x. You can choose whichever one you want to look at first, but I prefer to go left to right, but first make sure to read everything as a whole. So 3 more than 8 times the number x. We know that when you have more than means addition. So 3 more than whatever comes after that. 3 more than 8 times the number x. You can write this as 8 times x, but you know when you're multiplying a number and a variable, you can write those together. So 3 plus 8x. That is 3 more than, so 3 more than 8 times the number x is equal to 83. And we don't see only one that shows our answer. However, it is written in a different direction, but it's still the same answer. So this is wrong, this is wrong, and this is right. This would be your answer. So you see it's written as 8x plus 3, but that is the same as 3 plus 8x. You just moved it around. Alright. Question 5. Hannah deposited a fixed amount into her bank account each month. The function f of t equals 100 plus 25t gives the amount in dollars in Hannah's bank account after t monthly deposits. What is the best interpretation of 25 in this context? This is more of a rating interpretation type of question. What you do have to know is that this is the most important piece of information. T monthly deposits. So T is equal to the amount of months or monthly deposits. So we can make a little chart here. And we start off at 100. Let's go with 100 over here. And every month it increases by 25. Because what is going on every month? She is depositing 25 into her bank account. So here's month 1, month 2, month 3, and then you could do 125. So you could just make yourself a simple chart, but you could read all the answer choices first. D. Hannah made a total of 25 monthly deposits. No. That is not what it means. Remember, the amount of monthly deposits is represented by T. So T would have to be 25 in order for this to be true. But that is not the case here. Choice C says, after one monthly deposit, the amount in Hannah's bank account was 25. That is also not true. Because, remember, T is the amount of monthly deposits. So if we were to replace T with 1, we would get FT. And then T is equal to 1. Then we would get that she would have a total of $125 in her bank account. So that would also be, I should start crossing this out. Okay, B. Before Hannah made any monthly deposits, the amount in her bank account was $25. So basically this means that T is 0. It's not before anything ever happened. But we know that once T is 0, then F of T would be equal to just 100, because it would just get rid of this. And so choice B is wrong. Choice A says, with each monthly deposit, the amount in Hannah's bank account increased by $25. And that is precisely what we were saying with this chart. We started off with $100 on month 0, But every month she would make her monthly deposit, and it would increase by $25 because she would put $25 more. So answer choice A is the correct answer here. Question 6. A customer spent $27 to purchase oranges at $3 per pound. How many pounds of oranges did the customer purchase? So we know we can set this up as a ratio, which is basically a fraction. $3 per. You can always use the fraction to as a way of saying per. And then per 1 pound. Okay. And we know we want to figure out how many pounds, but we know how much he spent total. He spent a total of $27. So we're putting the equal values on the same side. So dollars will go in the numerator, pounds will go on the denominator. We don't know how many pounds. So like we did in, I believe, question 1, we can do the cross multiplication. Don't worry about the signs or the units, just worry about the values. So 3 times x would give you 3x. 1 times 27 would get you 27. And from here we have a one-step equation once again. Now we see that 3 and x are being multiplied, so we would do the reverse. Always think about these things in the perspective of x. It is being multiplied by 3. So we would divide by 3 to get rid of it. Same thing here, divide by 3, and you get x is equal to 9. So for question 6, the answer is x is equal to 9. Purchase 9 pounds. Nasir bought 9 storage bins that were each of the same price. He used a coupon for $63 off the entire purchase. The cost for the entire purchase after using the coupon was $27. What was the original price in dollars for one storage bin? So, it says Nasir. Here, we can use the skills we learned from the question that made us translate words into an equation. So, look at it like this. So, when it says, what was the original price in dollars for one storage bin? You could see this as price per bin, right? So, we know there was a total of 9 storage bins bought. And they all cost the same price, yet we don't know the price, so let's label it X. However, he used a coupon for $63 off the entire purchase, so we would subtract $63. And then the cost for the entire purchase after using the coupon was $27. So all of this, the original price of the 9 bins and the discount from the coupon will get you a total of $27. So from here, we just solve. So, and this is a 2-step equation because we need to do 2 steps to find x. So here, we can use PEMDAS again. So we work in reverse order because we are not like solving an equation like 1 plus 1 times 2, but we are solving for x. We're solving for a variable. So we look at subtraction. Is there subtraction here? And we immediately see that there is subtraction here. So we would do the reverse of that subtraction, which is addition. We're going to add 63 on this side, and whatever we do to the left side or to one side, we have to do to the other. So we add 63. This cancels out the 63s. You get 9x is equal to 90. Now from here, do we have any addition? No. Do we have any division? No. Do we have multiplication? Yes. So x is being multiplied by 9. Remember, you are looking at this from the perspective of x. So it is being multiplied by 9. In order to get rid of that 9, we would have to divide by that 9. This cancels out the 9. And 90 divided by 9 is 10. So x is equal to 10. So each of the storage bins cost $10. Whenever it comes to equations like this, it is important to double check your work. So let's look at the equation that we had originally and replace it with our answer. X equals 10. So 9, 10, 63. Sorry, this should be 27 because that's the equation. Equals 27. So we are trying to see if this equation, well, with our answer, if this equation is true. So now this is where we do PEMDAS in order. Do we see parentheses? Yes, but that is being used to replace the variable. So we don't see any exponents, but we see multiplication, which is 9 times 10. So let's do that first. 90 minus 63 equals 27. Now the last thing we see is subtraction. This gets you 27 equals 27, which is in fact true. So we know that our answer is correct. Question 8. For the linear function f, the table shows 3 values of x and their corresponding values f of x. Which equation defines f of x? In this question, we are given a really good hint that allows us to get rid of 2 answers. We are given the y-intercept. The y-intercept is the value of f of x when x is equal to 0. The reason it is called the y-intercept is because if you look at a graph, if you value 1, 2, but here would be 0. So I'm just drawing a random line. This has nothing to do with the question. But if we had a line like this, the moment where the line touches the y-axis is when x is equal to 0. So it's intercepting the y-axis, and that gets you in the equation y equals mx plus b. B is your y-intercept. So now let's go back to the question. X is 0 right here. And what is the value of f of x when x is 0? It is 29. So we know that the y-intercept, which we will write like this, plus 29, because we know that would take the spot of b, would be 29. And 2 answer choices, B and D, have the 32 and 35 as their y-intercept, and we know that is not right, so we can cross those out. Now we are left with A and C. So we have 29, and what you want to do here is look at the differences between each value. So let's focus on x first. From 0 to 1, we have 1. From 1 to 2, we have 2. From 29 to 32, we have 3. From 32 to 35, we have 3. So now you look at the corresponding values. They have to be on the same side. So 3 and the 1. Oh, I made a mistake. From 1 to 2, that would also be 1. and then same thing here. So these are the same, these are the same. So if you were to put this in a fraction, f of x can sometimes be represented as y. And you know the equation to find the slope, m, is y2 minus y1 over x2 minus x1. So let's just take any of our values. So we could use this as y2 and y1, x2 and x1. So 32 minus 29 over 1 minus 0. 32 minus 29, like we have said before, is 3. So 3. And then 1 minus 0, like we've said before, is 1. So 3 over 1 is 3. That gets us our slope. So now we can set the equation together. Y equals 3x plus 29. And like I said, y, it can be represented as f of x as well. So f of x equals 3x plus 29. Here's our answer, and that is answer choice A. Right triangles PQR and STU are similar, where P corresponds to S. If the measure of angle Q is 18, what is the measure of angle S? P corresponds to S. So, what this is saying? This is saying that the triangles are similar. The angle of the measure of angle Q right here would be 18 degrees. Now it is important to know that angles do not change despite the size of the shape. So if I were to draw an angle like this, and then I were to circle this and then make it bigger, it does not change the value of the angle. It would still be the same. So now we can use that knowledge for this question. It says that P corresponds to S. So let's find the value of P. We know that a triangle has a total, all the angles of a triangle must add up to 180 degrees. And since this is a right triangle, this makes it so much easier for us because a right angle is 90 degrees. Now we don't know P, so let's put X. So we know two of the values, and we know that they should equal up to 180 degrees. So let's put that as an equation. X plus 18 plus 90, which is the right angle, is equal to 180. Now let's just clean up this equation real quick. Let's add up 18 and 90. That should get you 108. So 108 equals 180. Now here we see that X is being, well, 108 is being added to X. So we have to subtract it to get rid of it. So let's get rid of that. And what we do to this side, we have to do to the other side. And that gets you X is equal to 72. And we know that P is corresponding to S. So they should have the same value of the angle. And that is the answer, B. All right, question 10. The scatter plot shows the relationship between two variables, x and y. Which of the following equations is the most appropriate linear model for the data shown? Okay. Now, it's important to look at these scatter plots, and if you want, you can make your own line of best fit first. Just to give you a rough estimate of what the equation is supposed to look like. So let's do that. I will make my line something like this. It's a little curved. That looks good. Okay, so that is my line. Now, it doesn't have to be perfect, because the process of elimination will really help you out here. First, let's look at our y-intercept. We see that our y-intercept is when, a reminder, is when x equals 0. So right here, x is equal 0. So we see where our line touches. We go all the way up, and we see that it touches somewhere between 9 and 10. Now let's look at the answer choices. Now this is written in a different manner. As we know, the standard equation for a formula is y equals mx plus b. But just realize that this is written as y equals b plus mx. It doesn't really matter which way it's written. You just have to know which values represent what. So now that we know that the y-intercept is these four numbers here. But like we said, the value of our line has a y-intercept of a number between 9 and 10. Now, answer choices A and B have 0.9, which is nowhere near between 9 and 10. So we can get rid of those. Now we're left with C and D. They both have our y-intercept, so let's look at something else. First, let's look at their difference. We see that C has a plus sign and D has a minus sign. This is a big piece of information because it tells you the direction of the line. For C, this represents a positive value of slope, meaning for every time x increases, y should also be increasing. But that is not what is happening here. Instead, every time x is increasing, we see that y is going down. So that is a negative relationship. So we can get rid of C, and we know that our answer is D.